All right, MathCounts, here we go. We got warm up 10 from the 2026 problem set. So I have to kind of go fast through this. I got something going on a little bit. So here we go. Double speed. All right, so a dog is tied to a vertical pole with a 13-foot long leash, and the leash is tied to the 5-foot is tied to the pole 5 feet above the ground, which is level and without obstacles. What is the total area the dog can explore in square feet? All right, so we've got the pole, the leash, and the distance over here. So the leash is 13, and the distance up the pole is 5. So what we have is a right triangle here. So we can use the Pythagorean theorem. And you can do a squared plus b squared equals c squared, stupid bell. Or you can just notice that it's a Pythagorean triple. This is a 5, 12, 13 triangle. So that's the length that we've got over here for the dog, but the dog can go all the way around the pole, and that's a circle. So this is actually the radius of the circle. So we would just do pi r squared and get 144 pi. Done. Moving on. That one wasn't too bad. Next one. What is the integer closest to the square root of 2026 plus the fourth root of 2026? Well, we know from last year's MathCounts competition that 2026 is really close to 2025, which is a perfect square. So this is really close to 2025, which is 45 squared. So this one, it's really close to being 45. This one is, oh dear. This one is the fourth root. So we can split it up into 45 and 45 approximately. But I need 4 of a kind because it's the fourth root. So what perfect square is closest to 45? Well, 49 is. So the closest I can get would be 49, which would be 7, 7, 7, 7. So we've got 4 7s right there. So this part here is close to 45, and this part here is close to 7. So 45 plus 7 is 52. And that is our answer for number 122. Next. A bag contains 4 red marbles and 2 blue marbles, and 2 marbles are drawn at random with replacement. So we're drawing it and putting it back in, so the probability is not going to change. The ratio of the probabilities that 0, 1, or 2 red marbles are drawn is A to B to C in simplest form, where A, B, and C are positive integers with no common factor larger than 1. Fine. What is the value of 100A plus 10B plus C? All right, so I want to find out the probabilities for 0, 1, and 2, and then turn it into a ratio. So the probabilities of getting 0 red marbles, 1 red marble, and 2 red marbles. There are 6 marbles, 4 of them are red, 2 of them are blue. So if I wanted to get no red marbles from picking 2 where I'm replacing them, then I would do 2 out of 6, that would be a blue, times 2 out of 6, or 1/3 times 1/3. So the probability of getting a red is 1/9, or getting 0 reds is 1/9. All right, now let's go to the end here. What's the probability of getting 2 reds? Well, it's 4 out of 6, or 2/3. So we could do 4 out of 6 times 4 out of 6, or 2/3 times 2/3. And that probability would be 4/9. Now to get 1 red, there's actually 2 different ways to do it. You can get a red, then a green, or a green, then a red. What we'll do is just find the probability of getting a red, then a green, and then we'll just double that amount. So we've got getting a red would be 1/3 of the time. or 2/6. No, that's getting a blue. Doesn't matter. And then 4/6 is getting a red. Okay, so I got a blue, then a red. So that would be 1/3 times 2/3, which is 2/9. But that is only the probability of getting a blue, then a red. We could have a second probability of getting a red, then a blue, which would be another 2/9. So this probability is actually 4/9. So we've got 1/9 to 4/9 to 4/9. That would be a ratio of 1 to 4 to 4. We can not look at the ninths. So the ratio would be 1 to 4 to 4. So we've got 100 times A, that's 100. And then B is 4. C is 4. So this would be 144. Next up, hate this problem. All right, what is the 2026th digit after the decimal and the expansion of the fraction 3/14? Well, first of all, we know that 3/14 is rational. Therefore, it is either a terminating decimal, so a decimal that will stop eventually, or it's a non-terminating repeating decimal, so it's going to repeat. Now, since we're going up to the 2026 digit, we can assume that there's going to be some repeating in this decimal. So all we have to do is find the pattern of repetition for this decimal. So this is long division. We're going to do 14 into 3. Oops, why did I do that? Oh, we'll turn this into a 2. So we got 28, goes in there 2 times with 2 left over, bring down the 0. Goes in there once with 6 left over. Remember, we're looking for when it repeats. So the next one, 4, that'd be 56. We've got 4 left over. It's not repeating yet. We want to see when this number repeats here, or when it repeats up here, either one. All right, bring down another 0. 14 into 40, that would be 2 times. That would be 28 with 12 left over. Okay, so it's still not repeating. Keep going. 14 into 120 is 8 times. I get 112. And then I've got 8 left over. Are repeating yet? Nope, not repeating yet. This is fun. So then bring down another 0. Gosh, 14 into 80. That's 5, so 70. 10 left over, still not repeating. Come on, seriously? Still not repeating? Yeah, not repeating yet. All right, 14 into 100, that would be 7. And then we get 98. 2. Oh, here's my repeating. See there? It's going to repeat at this point. Because now 14 into, we're going to get a 1. So it's going to repeat from here. This is my repeating portion right there. All right, so the first number is not part of the repeating pattern. I can tell it's going to start repeating at this point right here. Oh, you can't even see all the work. See how far down that way? This is a horrible problem. So it's going to start repeating at this point. So the next one's going to be 6, then 4, and so on. So it's going to repeat now. So this is my repeating portion. Okay, so I've got 2026 digits, but let's get rid of this digit here because it's not part of the repeating portion. So I want to know how many times I'm going to repeat this. I've got 1, 4, 2, 8, 5, 7. So I've got 6 repeating portions. If I get a remainder of 1, it's going to be a 1. This is a remainder of 2, remainder of 3, remainder of 4, remainder of 5. And if it goes in evenly, it's going to be a 7. So I'm going to take away 1 of these to get rid of this 2 right here. So I want to know I've got a repeating portion of 6 terms. I want to know how many times they're going to go into 2025. So 6 goes into there 3 times, 2 left over. 6 goes into there 3 times again, with 4 left over. 6 goes into 45 7 times, with 3 left over. So I've got a remainder of 3. So a remainder of 3 would be this number in the repeating pattern. So the 2026 digit would be 2. Ugh, it's the worst. All right, next one. A triangle has 2 sides with lengths 7 and 12. If the third side has an interior, let me get another piece of paper. This one's getting worked up. Third side has an integer length. What is the absolute difference between the greatest possible perimeter of this triangle and the least possible perimeter of this triangle? Okay, so the triangle inequality theorem says that the 2 smallest sides of the triangle their sum has to be bigger than the third side. And it makes sense. If you've got a long side here, the 2 shorter sides have to be big enough to meet in order to make it a triangle. So these 2 sides together have to be bigger than this third side. That's what the triangle inequality theorem says. So we've got 2 possibilities. Either these are the 2 smallest sides. In that case, 7 plus 12 has to be bigger than the third side. So the third side has to be smaller than 19. Now we have integer lengths. So we've got 7, 12, and then the biggest that my other length can be as an integer would be 18. So this would be my biggest perimeter. 7 plus 12 plus 18, what's that, 37? Okay, that's my biggest perimeter. Now the other thing is, what if 12 was the largest side of the triangle? Then we would say 7 plus the third side has to be bigger than 12. And then I would just subtract 7 from both sides, and our third side has to be bigger than 5. So we've got 7 plus 12, and then greater than 5, so the next integer bigger than 5 would be 6. So 13, we get 25. So it's the difference between 37 and 25, which comes out to 12. So here's my biggest perimeter, here's my smallest perimeter, then the difference between those two has to be 12. All right, we are moving. Next one. If a equals 2/3, what is the exact value of a plus a to the negative 1 power raised to the third minus a to the third minus a to the negative third? Express your answer as a common fraction. Okay, this one can be done just by plugging in 2/3. Remember, if you do it to the negative 1 power, that's the reciprocal. The first time I did this, I did it just straight through, pounded out the numbers. There's a lot of reducing at the end, but it's very doable. There is a faster way using binomial expansion. Since we have a binomial here to the third power, we can use binomial expansion and Pascal's triangle. I don't think I have a video on that. But basically, here's what Pascal's triangle says is you'd have 1 at the top, and then the numbers underneath it they look to the numbers above it to add up. So the number above this one is 0 and 1. And then this number is 1 because it's 0 and 1. But then this number would be 2 because these two numbers add up to 2. And then 1. And then the next expansion, we'd put a 1 over here. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1. So Pascal's triangle helps us with binomial expansion because the top is the expansion of the 0th power. Then this is the first power, this is the second power, and this is the third power. And we're doing this to the third power. So basically what this means is if I have a binomial and I take it to these powers, these are the coefficients in front of the terms. So for instance, if I take anything to the 0 power, right, that's always 1. So I just get 1. On this one, if I take x plus y to the first power, I just get 1x plus 1y. 1 and 1 are the coefficients. And then over here, if I do x plus y to the second power, this term is the square of this one. So it's 1x squared. This, the middle term, is one of these and one of these, because we're always going to do it to the second power. So it's one of these and one of these, so that would be xy. And then the last term would be 2 of these y's. 1 and then 2 y's. And then we've got the last one is x plus y to the third. This would be x to the third with a coefficient of 1. This would be a coefficient of 3. And we would use 2 of these and 1 of these to make the third power. So x squared y. And then the next coefficient would be 3. And now I'm going to use 1 of these and 2 of these, xy squared. And then the last one, I'm going to use 3 of these and the coefficient is 1, so plus y to the third. All right, so that's how Pascal's triangle works with binomial expansion. If we want to do the fourth power, it would be a 1, a 4, a 6, a 4, and a 1. So we could do the same pattern and just keep on extending it when we do binomial expansion. So how does it work with this one? Where we're going to let x equal a, the first thing in this one, and then we're going to let y equal a to the negative 1. That's the next part in this. So now we can replace, we need some more room on this one. There we go. Now we can replace all of these x's and y's with a's and a to the negative first. So let's plug in a to this one first. We get a to the third. Okay, then we're going to do plus 3. We get a to the second. And then 1 of these. So times a to the negative 1. The next one, we get a to the first. And then we've got 2 of these. A to the negative 1, a to the negative 1, which would be a to the negative 2. And then our last term here, there'd be 3 of these. So that'd be there's 1 of them, but it's a to the negative 1, a to the negative 1, a to the negative 1, which would be a to the negative 3. We can simplify in here. These 2 terms will simplify. We get a to the third plus 3, add the exponents, a, plus 3, 1 minus 2 is a to the negative 1, and then plus a to the negative 3. All right, why is this helpful? So basically, I have taken this and expanded it to this, and then look what I've got. I've got minus a to the third right there. So I can take away this a to the third. Then I've got minus a to the negative third. I can take away that. Here's what I'm left with. 3 times a, so 3 times 2/3, plus 3 times the inverse, or the reciprocal, sorry. 3 times the reciprocal of 2/3. That's 3/2. So 3 times 2/3 is 2. And then over here I got 9/2. So this is 4/2 plus 9/2, which is 13/2. And that's our answer. Whew. Yeah, I almost think that I solved it just as fast just by plugging in the numbers. But whatever, 13/2. That's a lot of writing right there. Beautiful. Yeah, if you haven't done Pascal's triangle, it is really helpful for binomial expansion. for finding the polynomial for a binomial where you're taking it to a different power. Anywho. All right, next one. A line passing through the point -5, 4 intersects the x-axis at A and the y-axis at B. The ratio of the lengths of PA and PB is 1 to 2. What is the slope of this line? Express your answer as a common fraction. Okay. So I'm just going to draw it out so we kind of got an idea of what's going on here. We've got a point over here, P, at -5, 4. That means this is 4 and this is -5. Okay, A and B are the x and the y axis. So the x-intercept and the y-intercept. Now the ratio says that the distance from A to P is smaller than the distance of P to B. So that means I'm probably going to make it like this, because I want this distance to be shorter than this distance. So I want to pull this line closer to this vertical section right there. Okay, so here's where A is at. Here's where B is at, somewhere up there. I'm not going to worry about that one. All right, so here's what I notice. I've got a ratio of 1 to 2 right there. All right, so what I have here is 2 vertical lines. They are parallel to each other. That means this big triangle here and this smaller triangle here are going to be similar to each other. These are similar triangles. And what I can now do is I know that this distance from here to here is 5. And this distance is, I don't know. So what I'm going to do is I'm going to use, what do you call that? What is it, side splitter? I'm going to use the side splitter theorem. I think it's called the side splitter theorem. I don't know, maybe it's not. But basically, the ratio of 1 to 2 should be the same ratio of x and 5. So I can say 1 over x should equal 2 over 5. They should break down to the same ratio no matter what, because these two triangles are similar to each other. And yes, I am using the reduced ratio here, but that doesn't matter because I could have reduced it myself anyways. So there you go. All right, so I get 2x equals 5. X is 5 halves, or 2.5. So this section is 2.5. Okay, what has that told me? It's told me now that the entire length from here to here is 7.5. So A is at -7.50. And now I can find the slope between these two numbers. So the slope of the line will be the slope between these 2 points right there. So using my slope formula, I can now just do 4 minus 0 over -5 minus -7.5. So I get 4 in my numerator. This is -5 plus 7.5, so that's 2.5. I shouldn't have decimals in my fractions, so I'm going to multiply the numerator and the denominator by 2. That gives me 8 over 5. Is that my slope? 8 over 5. Where's my answer sheet? 127. Where's it at? Ah, that was right. 8/5. All right, we're moving. Only got a few more minutes. All right. 2 parents and their 6 children go to a restaurant and are seated at a circular table. If the parents insist on sitting next to one another, how many seating arrangements are possible? Note that rotation and reflections are considered distinct. All right, so we've got, how many? We got 8 people. 1, 2, 3, 4, 5, 6, 7, 8. 2 parents, 6 kids We want to know how many combinations they can sit next together. Now, the two parents want to sit next together. And if I had 6 kids, yeah, I would want to sit next to as few of them as possible. So I'm going to say that here's the two parents sitting next to each other. Okay, so I've got the two parents there, and then I've got 6 places for the kids. There are 6 factorial ways that these 6 kids can be placed, which is 720? Yeah, 720. Now, those 6 kids can be placed that way, but then we can switch the parents. Like the dad can be here, mom can be here, or switch it, mom and dad. So it times this by 2, and we get 1440. So that's how many ways we can do it if the parents sit at these 2 seats. But we can move the parents around to 8 different positions. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 1. There's 8 different combinations where we can put the parents. So then we multiply this by 8. And now we've got a total arrangement of 11,520. And that is our answer. Last 2. Christopher is practicing archery with a target consisting of a center bullseye with 6 centimeter diameter and 3 outer rings, each with a width of 4. The bullseye is what percent of the target area? All right, so the bullseye has a radius of 3, so that would be 9 pi, using pi r squared. So 9 pi out of a total of what? Well, this is 4, 4, 4, and then 3. So that's 12, 15. So a radius of 15. 15 times 15 is 225. 225. So 9 pi out of 225 pi. Reduce that. 2 plus 2 plus 5 is 9, so 9 goes into that. 9 goes into that 25 times. We get 1/25, which is, we want percent, so that's going to be 4%. All right, last problem. Do I have any room anywhere? Here we go. Lyle has 120 toy soldiers, which he wants to arrange in a rectangular formation with no more than 20 soldiers in any row or column. What is the sum of all possible numbers of rows that Lyle's formation can have? All right, so we just need to break up 120 into different factors. So we can do 1 and 120, but 120 is more than 20 soldiers in a row, so that won't work. 2 and 60, but 60's bigger, that doesn't work. 3 and 40, nope, 40's too big. 4 and 30, nope, 30's too big. 5 and 24, nope, 24 is too big, so that's not going to work. 6 and 20, okay, here's the first one that works, 6 and 20. Now I can do it both ways. I can do it row of 6, column of 20, or vice versa. So I can add both of those numbers. 7 doesn't work. 8 goes in there. How many times did it go in there? 15 times. And then we've got 9 doesn't work, 10 and 12. Okay, so my row can be 6, 8, 10, and then my columns would be this amount. Or my rows can be 20, 15, 20, 12, and then my columns would be this amount. So basically, I just have to add up these 6 numbers. 6 plus 8 plus 10, 24, that would be 24. Here we've got 27, 47. 24 plus 47 is 71. That's our answer. Done. All right, keep mathing hard. I will see you next time. Bye-bye.